If you are working on any of the mission critical sector, especially if you're creating SaaS or if you're creating application in the mission critical sector like healthcare, or maybe for aerospace engineering or aerospace sector, or maybe for legal sectors, then the importance of STT, which is speech to text, is really, really critical. This is especially when you are creating any voice or multimodal application. And the reason is because STT becomes the first interface where your user will interact, right? Even if you're creating a voice AI agent. So the room for error is really, really less there because, especially in healthcare, if a patient interaction or a doctor interaction is being understood by your STT model wrong, then it is likely that the AI output that will be produced is going to be wrong. And this is going to actually cost lives. So that is why when you build for enterprise or when you build for any healthcare application, which is what I have been trying to do for last couple of weeks, which you will see probably in coming days, the STT becomes really, really one of the area that I was focusing a lot in the last few weeks. And in this video, what I've tried to do is I have able to, I think, find out one of the really good STT model that have recently been launched by Assembly AI, and it is in public beta, of course, which I will show you with the benchmark. And of course, as you know, I am not a big fan of benchmark. So what I'm trying to do as well is creating a tool where I can do like comparison and of different STT models. So because as I said, for healthcare, I really had to ensure that the STT models produce exactly accurate output. So let's not waste any more time. Let's go to the screen and let me show you what I've been trying to build while also tell you about this new STT model that has just came up, I think around a week now for public beta. So we will also compare it with OpenAI and see how better it is. So let's go to the screen. Let's start the video. To start this, let's actually first try and run this application and do the comparison between the Whisper model and these Assembly AI's new model. So I'm just going to run the application. By the way, so this is the actual transcript which we are going to test with this STT comparison tool. So just to compare STT quality, and I think this one with the disfluencies. According to Rajagopal et al., 2023, in the New England Journal of Medicine, Volume 389, Issue 7, pages 623 635, the novel CRISPR-Cas9 therapeutic approach demonstrated statistically significant p-za 0.01 reduction in tau protein aggregation in patients with early onset Alzheimer's disease. The pharmacodynamic profile indicated a 73.8% decrease in phosphorylated tau levels in cerebrospinal fluid after 12 weeks of treatment. However, and this is really important, the authors noted a 17.2% incidence of transient immune mediated encephalopathy that resolved within 48 to 72 hours without sequelae in all but 2.3% of affected participants. The question remains, does the benefit risk profile justify expedited approval under the FDA's accelerated pathway for neurodegenerative conditions? Okay, so now this one we have generated as a STT model with OpenAI and Whisper and the Assembly Slam one. Now, if we do a quick comparison, you see that first thing is these disfluencies, which is like this, all these disfluencies is not present in the STT that is being produced, which is okay, but not always okay in case of an enterprise system, because in enterprise system, you probably want all the disfluencies and question marks and different other emphasis should be generated as part of STT, because that is what actually defines the tonality of someone's voice. And an AI agent should be able to also understand the tonality, because not all of the time a human is, let's say, asking questions in a proper grammatic oriented English or sentence, right? Sometimes we use normal statement, but we ask it as a question. So the tonality actually creates that emphasize on the questions, right? So that is why this sort of disfluencies are important to be captured in an STT model. However, when we see the STT output from both OpenAI and the Assembly's Slam one, we see that both of these models have failed to produce these disfluencies. Now, the second thing is, if we carefully look to the original transcript and the transcript that is produced by OpenAI's Whisper, here it produced Casper Cas-D, whereas the original transcript had Casper Cas13D. And this is what Assembly AI was able to properly produce. And this is significant because, thinking from a medical application point of view, if there could be a difference between CRISPR-Cas9 and CRISPR-Cas13D. So this is really essential that the voice AI agent or any of the multimodal AI agent that we are trying to create and deploy in a mission critical applications, especially in the healthcare, our AI agent is able to grasp the STD input or the human input properly. And remember, here we are using really good audio, like a really good quality audio. In a real world voice AI agent application, that will not be the case. In a real world application, there will be background noise, there will be different accents of different humans, and the model or the voice AI agent should be able to work in those situations as well. Like, this is the actual, I would say, challenge in creating a mission critical AI application or an enterprise AI application. However, we are seeing that Slam 1 is actually better at tracking different keyword, and I have actually created many MP3 files. So I think over 10-15 MP3 files, which I will play rest of this video and show you the differences, and then I will also discuss about few of the features of this STD model. Now let's go ahead and then just see some other. Here we see that the reduction of tau protein aggregation, whereas in the OpenAI's Whisper, it says tallow-protein aggregation, right? However, when we see Assembly AI, we see it's tau protein aggregation. Again, another proper identification of the medical term, which is where I can see Slam 1 is much better than Whisper. And now going through the rest of the transcript, I can see that both Whisper and Slam was able to create the transcript properly. So there was no issue, but we have been able to see that there are only two areas where Whisper has failed, whereas Slam 1 have been successful. So let's actually go ahead and explore what we have tried to do as part of this particular code, and then we will run a few more examples in few different sectors. Like, we'll run for sales, we'll run for legal, and we'll run medical applications, and see whether this output that is being produced by Slam 1 is actually consistent, or is it just this one as an example has worked but the other one will fail. So let's see, and let's go through the actual Assembly AI paper to understand this new STD model and why this is really important for me, especially when we are trying to create mission critical application with AI. So let's first run through the tool quickly, what we have done and how you can actually use the tool. Then I'm going to quickly run through this new STD model. So if I just run this tool quickly, so basically what I'm trying to do with this tool, I'll actually continue create this tool much more improved version, and you should be able to also use it, is here I have added a TTS and STT models as a provider. So at the moment we have OpenAI, Cortesia, and Assembly as a provider, but we can add more and more providers for our benchmark testing. And then I have created a bunch of audio files, sample files, but these are mostly I've generated manually. But I currently am working on creating the audio file from within this utility. So basically, when you go inside this first option, it will ask you what is your TTS provider. You select the TTS provider, select the voice, and then you can select different samples. So these are like the transcription, and it will use and generate the audio itself, and it will automatically save it into the audio sample folder so that we can use those and test it. This is what I'm working on, but at the moment it's still not ready, which will be ready hopefully in a few more days. Then next options that we have created is compare STD quality. So when we do compare STD quality, what it is doing is going through the audio sample that you have generated either manually or through the TTS engine or the TTS program that we have created, and then it will run each of these audio sample based on whatever you want to test, and it will send this to different providers. At the moment, it is sending to OpenAI and Assembly AI for comparison. In tomorrow or in future, I'm gonna add deepgram and all the other popular STT engines so that we are able to do some comparison test quickly. And you don't have to actually listen to my video or any other video in the internet. You can simply fork this tool, run this tool in your local, and do your own comparison just to find out, sorry, what STT model is perfect for your application. The third thing, or the third options that we have is testing advanced feature. So we want to test contextual prompt. So that means, for example, about assembly AI, when I'm going to talk, I will talk more about what is contextual prompt, how you can test different disfluencies and emphasis and questions in, let's say, some of the transcript, so that you are able to test the STT model whether it is able to properly categorize disfluencies and emphasis or not. And then maybe some STT model will have some more features which we will add in this menu as well. You can also test key terms. So when we say key terms, that means is basically when you provided an audio file with some key terms, then the STT model is able to actually identify those terms properly. Or if you provide context, it is able to understand those words properly. So these are all these features, again, going to discuss in this video little more details. But this is also I'm trying to build inside this tool so that you would be able to also test this extra features with whatever STT engine you want to use in future. So this is the tool all about in a very, very high level. If you want more code deep dive of this tool, let me know. But I don't think this is really, really important, because you will have access to the code base yourself. But if time permits, I'm just going to quickly run through the code base, how it is working. Now let's quickly go back to the Assembly AI's blog, and let's just see what this new model is all about. So this is just released, as I said, in public beta about a week back, so April 23rd, 2025. It is not a new model as per se, so it was actually launched, I think, few months back when I have seen this. And then this model is called SLAM model, and it is, as they say, is a powerful prompt-based speech language model. So it is also customizable to transcription needs. So generally speaking, if you have an STT model, and then if you want to use that STT model for a specific application like healthcare, you usually have to do some more fine tuning to your domain, right? So this is what they have done is they created a model where you don't have to retrain the model. Rather, you can actually provide the contextual information or key terms up to 1,500 words, and then this model would be able to perfectly analyze or perfectly detect those particular words in when there is a speech coming up. As they say that it is superior accuracy that human prefers. So that means that what they're saying is over 72% human preference have rated this model over deepgram's Nova 3 model. Again, the deepgram's Nova 3 model is a really powerful STT model, but it seems like slam 1 is even better. So I really also want to test this comparison between Nova 3 and slam 1 with all of these mp3 files or this text, these sound files that I have generated basically. So as you can see that here, as you can see in this graph, they have actually shown you the error rate comparison. So universal model, in case of formatting, there was more error in universal model, whereas slam has a less error. So it is producing more key entities properly, it is able to do formatting accuracy properly, and it is also able to do general accuracy. So general accuracy is on different diverse set of data that they test this model, whereas in formatting accuracy they would check different punctuation, spacing, and encapsulation, and all this bit, it is whether it is coming properly or not. In our example, let's just go to the output. So I don't know which one is the latest. I think this one is the latest, right? So for example, here, this is encapsulated properly, right? So this is what is meant by encapsulation and all this. So that's what they are saying, that this model is able to do this much more better. Whether you need cultural medical terminology, a technical product name, or legal citations or industry specific acronyms, SLAM1's multimodal architecture understands the semantic meaning and context of the terminology that you provide to correctly focus words in the transcript. So basically, what they are saying is the missed entity rate, or MER, is actually less, especially when you give prompt. So what is missed entity rate? First of all, missed entity rates is when you give spatial entity or spatial acronyms or stuff. Then STT models, if it is missing those entity when it is producing the transcript, that's called missed entity. And the rate for on an universal model, by universal model they mean their own universal model, but this is also generalistic. They are saying that the other general model like Nova 3, the missed entity rate is 30.56, whereas with SLAM it is reduced. But this is all without prompt. When you give the prompt, when you give some contextual understanding, when you give it some related prompt or related keywords, then the missed entity rate is 10.10%, which is really really good, I would say, especially in a medical application. This is the reason why I have been looking for it, because I have been working on a new startup which we are trying to build in the healthcare. This is the one you will know about it in coming days, of course. We are trying to build this particular startup in the healthcare sector, and this is the reason why I was more looking into these STT models in more details. And they have given a couple of examples like medical doctor consultation. They said that entity rate error they have reduced by around 66%. So that means it is able to identify medical keywords in a better way than general models. And this has really been a problem when I was testing the healthcare application myself. Sometime when I was testing this doctor voice agent and I was asking different questions in the medical field, he was not able to actually understand those medical terms properly sometimes. Also, in case of legal proceeding, we know there is a large chunk of different vocabulary that is being used, which is not like a normal English, like voir dire or a miscacure. All this, even I don't know if I'm pronouncing is right or not, but this is what this is able to actually do it with better quality. And I'm going to quickly run through few of this legal proceeding and medical doctor consultation and sales discovery call. I have created some transcripts, some voice output that I was actually testing this model with. And this is the best part of this STT model. So we can actually ask SLAM1 to capture the disfluencies, emphasis, and sentiment. This is really, really important, as I was also showing you in the demo. It is not available today. They are saying soon SLAM1 will offer you control over how speech is represented in transcript. That means we would be able to actually capture the disfluencies and emphasis and sentiment. If we are able to do that in a TTS model, what that does is it improves the quality of voice AI agent, because then we would be able to capture the tonality of the voice from users or the speakers, and then the AI agent will be much more, I would say, matured or more human centric in terms of when it's producing output. And in terms of cost, again, this is only $30.37 per hour, which is really, really cheap. But this is actually great when you are not streaming. So if you're streaming it, then I think this cost would become $0.47 per hour. Go ahead into their console. They actually give you $50 free credit to test as well. So go ahead, sign up, and then test this model with the $50 free credit. And as I said, when I was testing, all these features were not still available, so these are all still upcoming. But maybe by the time you are watching this video and you would test it, you will obviously see all of these features there and be able to test it as well. Please let me know in the comments if you're able to test it properly. So this is the section of the blog which is inside the console or the playground, where they say that improving transcription accuracy by leveraging SLAM1's contextual understanding capabilities by prompting the model with certain word or phrases that are likely to appear frequently in your audio file. So what they are trying to say is you do not need to fine tune the model as opposed to you had to do previously when you are actually using in a specific application like healthcare or in a legal sector. So it's a provide up to 1,000 domain specific word or phrases, maximum 6 word per phrase that may appear in your audio using the keyword key terms prompt. So if you provide this, then what will happen is, even if you give a muffled audio or not a very high quality audio, or even audio with some background noise, this STT model would still be able to produce the STT output in a high quality properly. So this is really, really important, and 1,000 words is really good, I would say, because generally when you create a specific sector specific voice AI agent application, I think 1,000 critical words in that domain will actually improve the accuracy of your overall voice AI agent platform. So I think this is good thing that we don't have to do fine tuning. This is what I have been thinking in my mind for this Hexicare, that we have to do a lot of fine tuning for STD model or AI model. But I think if the Slam one works, because I'm gonna do test with the Hexicare agents, and if it works, then this is absolutely fantastic. Then we don't have to actually spend a lot of the cost in doing fine tuning, because as a startup, fine tuning is one of the largest cost in terms of the IT and infrastructure. So we want to avoid that at the very early stage. And if we can use things like keyword prompt or key terms prompt and produce a better STT output without delay, then I think this is perfect. Having said that, now we'll go ahead and test a few more examples, MP3 files that I have created, which are really, really complex, and see if it is able to produce those properly or not. So I'm back here in my VS Code, and then let's do again another STT quality test. And this time, I think I'm going to test some medical crossover with Southern accent. So that's a different accent, and see whether it's able to produce the STT properly or not. Y'all need to understand that the plaintiff's traumatic brain injury resulted in post-concussive syndrome with vestibular dysfunction, which substantially impaired his ability to perform activities of daily living. The neuropsychological evaluation demonstrated significant deficits in executive function, warranting long-term disability benefits under Section 501(c)(3) of the insurance policy, and I ain't just whistling Dixie. So here, if we see that in this scenario, I think Whisper was able to categorize this 501(c)(3) properly, whereas Assembly has just said Section 501 of the insurance policy, which is wrong here. And this is exactly what I was saying, that this application will help you do that. You don't have to just follow a blog and trust it. You can actually literally create different voice examples and test it whether the claim is true, or whether you need some more fine tuning, or this model is perfect for your voice AI agent or for your sector. Let's try another one. Let's see what we have. Let's check a legal depositions. Counsel has filed a motion for summary judgment in the Duran v. Peabody Coal Company case, arguing that the plaintiff failed to establish a prima facie case for negligence. During voir dire, several potential jurors expressed concerns about the impartiality of expert witnesses. The amicus curiae brief submitted by the Industry Association raises important questions about the standard of care. We're seeking both punitive damages and declaratory relief based on violations of substantive due process. Yep. So with this example, as you can see, Whisper has failed. So Whisper says during war and ire, whereas the actual medical term is war and dear. So this is again one of the example where if you are trying to create it for a legal applications or law related voice AI agent, this kind of STT model will actually help you, get a bit better result, like 1 or 2%, 3% better result, which is what matters a lot in an enterprise setup, as I have been telling you. Let's test another one, and then we are going to actually wrap up the video because it's already becoming very long. So let's test something really complex. I don't know, this one we have tested. Let's test this one, medical consultation with disfluencies for disfluencies. Let's see. Looking at your test results, I can see that you're A1 7.2, which is slightly elevated. We should really consider adjusting your metformin dosage from 500 milligrams to 1,000 milligrams twice daily. Have you been experiencing any symptoms of increased thirst or frequent urination? The peripheral neuropathy in your right foot could be related to the diabetes progression. Looking at this, and again with this voice, I have intentionally added some background noise just to see whether the STT model is able to perfectly get this output properly or not. Now let's see where it deviated. So we should really consider just, I think Whisper model was actually a bit better in this case. It was able to actually produce this word is properly, whereas assembly model have actually haven't focused on that particular word. I think what I'm gonna do is I'm gonna test one of the advanced feature, for example, with key terms, or maybe let's test the key terms. Let's test the technical cells and see whether it's able to find out it properly or not. Now, if you see, this is really interesting. So when you provide key terms and when you do not provide key terms, how much difference this output comes up. So with this particular voice that we have sent, it says here, it says ZeroSync Pro TM version 721, and here it actually correctly says ZeroSync Pro TM version 71. Now if you quickly see in the advanced feature, when we have provided the prompt properly, like here, the sales prompt, in the prompt we have given ZeroSync Pro as a prompt to the TTS, to the STT model, and then when we have provided that and it has played that audio, it knows that it's ZeroSync Pro TM. When we haven't given this prompt key terms and just send the audio in a clean way and tried to do this speech to text, it was not able to properly come up with the term here, as you can see. And this is what, as I said, it is going to make a lot of difference when you're creating an enterprise system or a healthcare system or legal applications. And we can go ahead and test all of these features. There are actually a couple of features that I have been testing since yesterday. Please go ahead, clone this repository, and maybe just test with it. I will put all of this mp3 file as well in the repository so that you can go ahead and test it of all the different features. And please let me know in the comments if you want me to add any more providers that you are probably using in your voice AI agents, so that I will add that into this particular project so you can do all of this comparison. One of the last thing that I'm going to run, and then I'm going to end this video. So let's run something with New York accent, which is pharmaceutical, and let's see whether it's able to produce. And here we will test with the all, because we are going to test disfluencies, emphasis, questions, and everything, and see how the response comes up in the STD transcription. Now here, interesting, when we have given this particular New York accent, let me see if I can play this accent for you. This is medical, and this is pharmaceutical New York accent. Listen, we're talking about a novel monoclonal antibody that targets the interleukin 6 receptor, right? It's showing promising results in phase 3 clinical trials for treatment-resistant rheumatoid arthritis. The pharmacokinetic profile is favorable, with a half-life of approximately 28 days, allowing for monthly subcutaneous administration. Fuck d'appetit if you think the competition is going to beat us to market. So as you can see, when we have tested all these three, like disfluencies, emphasis, question, and in the advanced feature, if you see how these are being tested, we are actually prompting the STT model that please capture all the disfluencies and repetition. Please capture all the emphasize and make it like wherever it is capital, make it caps or indicate emphasis. Or if there is a question, add question mark. So when we are giving this sort of prompt to the STT model, it is able to actually add the comma properly, add the question mark properly, even I don't know how to even spell it in the New Yorkish language. This is also like came up exactly we have generated with the STT model with Cartesia or with 11 Labs. And this is something that I'm really, really fascinated, I would say. So yeah, well, again, please go ahead, download all of this file, test it yourself, and let me know what do you think, whether we should add more and more provider to this application. You can actually fork and add more provider and raise a pull request as well. I'll happily approve it, and I'll happily add it there if you want to actually take it and make it more sort of a benchmarking application. That's what I'm trying to build, so that we can actually benchmark different STT models properly and test it properly, so that we can really create production ready enterprise grade systems. With that said, I'm going to end the video. I really hope this video has given you some value. If yes, don't forget to give it a like. Don't forget to, because there is a lot more these interesting videos are coming into the channel. And please take care, and I'll see you on to the next one. Bye.